All right, here we go with 4.11. Today we're going to identify key features of sinusoidal functions given graphs or algebraic representations. So we've already been doing this, looking for amplitude, midline, period, maximum and minimums, so on and so forth. And we're going to add just a few things today, one being average rate of change, and then also where it's increasing and decreasing. That's going to help us when we look at real life situations, because these are things that we want to know about real life values. To get us started, this is a question that is similar to the one that we looked at the end of class on Thursday. And here we want to write a sine and cosine function which could represent the graph below. So go back to your notes, make sure you kind of have an idea of how the process, what you need to find in order to create your function. Give it a try. Make sure you separate your paper. You can do it horizontally or vertically, but a space where you're going to work on it on your own, and then we'll take a look at it together. Right, so here I've just written the general form for any sinusoidal function, whether it's sine or cosine, and there's just a couple things that we know we're going to need to look for. The first thing that we can think about is, all right, what's the midline, and then when I know the midline, I can figure out what is the amplitude, right? Another thing that I can then figure out is, all right, well, what's the period going to be, right? Not too hard. And the two things that are linked are, okay, do I want to use a sine function or a cosine function? And depending on that, what is my phase shift going to be, right? And so these two are linked, and we kind of look at those last. So going through this, let's just, since we have to create a sine and cosine function, let's think about, let's find, the amplitude, the period, and the midline first. These are, of course, not linked. The amplitude, period, and midline won't change based on sine or cosine. Those are going to be the same. So we find those first, and then we can create our two functions. So if I am looking for the amplitude, I would like to find the midline first. And the midline is, right, the distance that is in between the max and the mins, or not the distance, but the line that is in between the max and the min. So the max is at 2, min is at -2, and so this midline is going to be the x-axis, which is y equals 0, and that of course means that the amplitude is going to be 2. Okay, so now let's look for the period. So the period is going to be the distance in between the maximum or minimum points. And so I can think about, here's one maximum. This appears to be halfway to pi over 2. So this would be pi over 4. And this other maximum is halfway between negative pi over 2, negative half of pi, and a whole negative pi. So that's negative 3 pi over 4. So this distance here is from a positive pi over 4 to a negative 3/4 of pi, and so that's going to be a total of pi. So the period, remember, is 2 pi over the absolute value of b, and in this case that period is 1 pi. So the value of b in this case, the value of b has to be 2. Equal 2. It could of course equal -2, right? The absolute value of -2 would also make this work. But let's just work with the positive here. We will see some examples of negative in a little bit. Alright, so now I have the basic shell of my function. I know what the amplitude is, I know what the midline is, and I know that the value of b here is 2, since the period is going to be just pi. And so I'm going to write two functions, and they're all going to have an amplitude of 2, and I have a b value of 2, and they have no midline. The midline is 0, so k value is also 0. And then let's write the second one. So let's make this one, let's do the sine first, and then we'll have 2 cosine 2 times x minus. Okay. So looking at sine first, so what do we know about sine? Remember those key characteristics, right? So sine is always going to, unless there's a phase shift, it's going to start at the midline. And its origin is going to be at the midline, and then it's going to increase, right? Think about sine. Sine is the y-coordinate, and that is increasing on my unit circle. So it turns out here, look, I'm in great shape, right? Because this is exactly what happens here. It starts on the midline, and there's no phase shift that needs to happen in order for me to start on the midline. So for sine, the phase shift is going to be 0, and I could even rewrite this inside piece as sine of just 2x, right? Because x minus 0 is x. For cosine, right, the origin would need to be on the maximum point, right? And then it will decrease. So the problem is the origin here isn't, the maximum is not occurring at the origin. The maximum occurs pi over 4 units to the right. So this distance here is pi over 4. That's how far this function that I'm graphing has slid to the right, has been translated to the right. And so the phase shift, in order to make this a cosine function, would have to be pi over 4 radians to the right. And so my h value will be pi over 4. Okay. Now we're going to go ahead and move on to a question which asks us a few more questions, not just to recreate the graph, but some questions about the sinusoidal function itself. Alright, so given this graph below, indicate two intervals for which the average rate of change is 0. So we might want to remind ourselves, what is the average rate of change? How do we find the average rate of change? And the average rate of change is, on average, between 2 points, how much are you changing? Okay, so I want you to just take a look at the graph and try and pick 2 points on the graph where, on average, if you were to go from one point to the other, your rate of change, the amount you're changing, is 0. Alright, so there are infinitely many options, really. The first that I will think about are just thinking about these 2 points here. Okay, so if this is my first point, and let's say this is the point that occurs at 1/2, and this is the point that occurs at 2 and 1/2, well, here I'm at the value 3. When I get to 2.5, then all of a sudden I'm again at the value 3. So the average rate of change between these 2 points is going to be 0. So the interval, one interval, will be the interval between 1/2 and 2 and 1/2. Okay? Now I want you to find the second interval, another interval, on your own, and I want you to try and pick 2 points between which you're choosing which are not maximums. Alright, so I hope that you picked one that makes sense. Let's just take a look at, for example, 2 points between which the function is 0. So here the average rate of change is going to be 0, so if these are my 2 points, one point here, another point here, right? When I go from this point to this point, I'm back at the same value, at 0, right? So the average rate of change between here and here is going to be 0. On average, I'm not changing at all between this point and that point. And so I could say here, let's say that point, that occurs maybe at 1/4, and this occurs at 3/4. Maybe that's a little generous. Maybe we could say this is 1/6, and this is 5/6. So perhaps the second interval would be between 1/6 and 5/6. Okay. Important to remember what the average rate of change is, right? It's just the total change that you have gone through between one point and another, divided by the total amount of steps that it took. So, for example, if I were going to compute the average rate of change between the point that I get at 1/2 and the point I get at 2 and 1/2, Well, here my value is 3. Here my value is 3. So the total amount of change from this point to this point is 0. And I'm dividing it by the number of steps I took, which is 2, and 0 divided by 2 is 0. So the average rate of change is 0. Okay? All that really is the slope of the line that connects the 2 points. Right? So for example, if I were trying to connect this point to this point up here, I'd have a positive average rate of change, right? This point up here is at 3. The point that I started at was at 0, so the change between 0 and 3, well, that's 3 minus 0, that's a change of 3. And that occurred, we could say, maybe over a half or 0.5 of an x value, right? I'm going from here and then up to here. That happened over about a half. And so what I would end up with is 3 divided by a half, which is of course 6. So the slope of the line between here and here has a slope of 6. Okay? Just a little review. So given interval over which the function below is increasing and an interval over where the average rate of change is 0. So here we want to think about what is our game plan going to be. So there's a couple of different things that you could do. I want you to pause and just think about what is the most likely way that you would go about trying to figure this out. Maybe you said create a table. That would work just fine. Maybe you just want to think about the values that this function will have. You can do that as well. I would recommend that the most fail-proof way to do this is to actually sketch a graph. Okay, so go back and maybe review how to graph functions like this. It's definitely a good review because we're going to need to know how to do it very well. And then use that graph to give intervals where it's increasing and where the average rate of change is 0. Couple things to note. You want to think about, okay, once I have my graph and once I figured it out, how could I have figured this out without the graph? Okay, and be prepared when you come in on Tuesday. We're going to try doing this without the graph with a sort of different function. I will say this, when you're graphing this function, use a graph where you're counting your intervals on the x-axis by integer values. That will make it a lot easier on you. All right, we'll take a look at this. Make sure that you have some questions written down if you get stuck, and give it your best shot, and we'll see you on Tuesday.